So we will be looking at quadratic functions, and we're going to start off by looking at this question, 3.2. It says use a quadratic formula to solve the equation 9x squared minus 24x plus 25 equals 0. First thing we're going to do is write quadratic equation. Identify A, B, and C. Now plug in the numbers. You can use your calculator if you wish to do some of these computations. For example, 24 squared is 576. So we can write this out. It's 24, 576 minus 900 over 18. Just do that computation real quick. Minus 900 is negative 324. So we got 24 square root of negative 324 over 18. Of course, we have a negative square root here, so that's going to pop out to be an I. So 24 plus or minus square root 324. I is on the outside of the square root. And now we just need to simplify this by seeing what the largest perfect square that divides into 324 is. Let's start with 16. No. 324 divided by 4 is 81. So it breaks down into 4 times 81. So 24 plus minus square root of 4 times square root of 81. I over 18. So that's 24 plus or minus 2 times 9, which is 18 over 18. I. And this I goes along with this term here, second term. And this simplifies into 24 over 18 plus or minus 18 over 18I, which is the same thing as 12 over 9 plus or minus 1I, or just I, which is the same thing as 4 over 3 plus or minus I. So the two complex solutions are given by x is equal to 4/3 plus or minus I, giving two complex solutions. Let's look at the next problem. In this problem, we want to place this quadratic into the standard vertex form. So, standard vertex form, let's use method of completing the square. So in this method, we have y equals we want to take half of the middle term, that's half of 14, and square it. So 14 divided by 2 squared is 7 squared, which is 49. Now, according to the method of completing the square, we want to add 49 to each side. Now, on the right-hand side, you'll notice that the trinomial factors is a perfect square trinomial. X plus 7, quantity squared, plus 48. And finally, we can subtract 49 from each side to solve for y. So y is equal to x plus 7 quantity squared minus 1. Sometimes this is also written y equals x plus 7 quantity squared plus a negative 1. In this problem, this would be our answer, since they're looking for x minus h squared plus k. This tells us the vertex v is equal to negative 7, negative 1. Let's look at the next problem. Rocket is launched at 0 seconds. Its height is given by this. When does the rocket splash down? In other words, on this first part, we want to know for what time t does h of t equal to 0? Well, you set the quadratic equal to 0, and you solve using quadratic formula and your calculator. Now, for brevity, what I'm going to do is I'm going to calculate b squared minus 4ac in my calculator. So that's the radicand. So I have 100 squared minus 4 times negative 4.9 times c, which is 269. This will give me this number, 15,272.4, and I want to take the square root of that in here. So far, what do I have? I have negative 100 plus or minus square root 15,272.4 over negative 9.8. Let's go ahead and calculate that out. So there's going to be two possible solutions, right? But only one will be the actual solution since we're dealing with time, t. Should be careful with the variable here. Variable is t. So we have t is equal to negative 100 minus square root 15,272.4 over 9.8. Or we have one where it's positive in the middle. That's a plus sign, 15,272.4 over negative 9.8. And let's compute these using our calculator. So we got negative 100 minus square root. And that's going to be divided by negative 9.8, 22.814. Seconds. Or it could be the same thing, but with a plus sign in the middle. And then you divide that by negative 9.8. Negative 2.41 seconds. Now we immediately disregard this second solution here, called an extraneous solution, because we're only dealing when time is 0 or positive, that is when time is non-negative. So that means that the rocket splashes down after approximately 22.814 seconds. The second part of this is how high above the sea level does a rocket get at its peak? That's a question of what is the vertex? So the vertex can be found using our calculator quite efficiently. So if you go to a calculator and you plug in negative 4.9 and y equals x squared plus 100 x plus 269. And of course we're going to need to adjust our window because we know the rocket starts at 269 feet and the time it hits the ground is 22 seconds, so the max time would be 25, let's just say. And let's say the Ymax is 500, that's the highest that the rocket will go. Although this is just an estimate. We see the rocket goes outside of our window, so we go ahead and make this larger, like 1,000. There we see a pretty good picture. There's the vertex. That's how high it goes, the y value. So we want to do second, calc, maximum. That's option 4. Make sure your cursor is on the left of the maximum. Press enter. Make sure it's on the right of the maximum. Press enter and press enter again. So the maximum value is, or maximum height is going to be given by this. So max height is y is equal to 779.204 feet. And there are ways of doing this algebraically, for example, by completing the square, or by finding the axis of symmetry, and then by finding f of a. So if you want to do an alternative approach without using technology, would be to find the axis of symmetry, also called AOS. X is equal to negative, or in this case t. T is equal to negative b over 2a, and then you'd compute f of negative b over 2a. And this would be our max height. So you just use the coefficients up here. B would be 100, so it would be negative 100 over negative 9.8. And then you compute f of this. You evaluate the function. And you should get the same exact y value. On a test, it'd be best to do both, that is, check using your calculator, but also by computing the axis of symmetry and f of the axis of symmetry. Alright, let's look at this problem. This is our final problem, one of the final problems. I think it's the final problem in here. On this problem, they say just write the quadratic equation in any form of this. So here this has to do with transformations. And what are we doing here? We're starting with a function that's x squared. That's just a parabola. That's a parabola centered at 0, 0. That is, the vertex is at 0, 0. It looks just like this. It's one of our, what we call toolkit functions. Toolkit functions, or parent, also called parent functions. This is a big list in your book. For example, there's this one, there are lines at y equals mx plus b, there's the absolute value function, there are other functions as well. This function represents the quadratic function shifted left 1 unit. So how do I do that? Is I'm going to shift this left 1 unit by computing f of x plus 1, which is x plus 1 quantity squared. That's it. That's the equation of this parabola. Sometimes we get to give this new function a simpler name. Sometimes we call it g of x. Of course, this is just only one transformation of the plane. You can have other transformations of the plane. For example, you could have horizontal stretches or compressions. You can have, vertical stretches or compressions. There are other transformations of the plane that we should be aware of. And we like to kind of see here if indeed this is okay by checking our work. So let's take a point here, evaluate it at -1, and the y value should be 0. It's pretty evident that the y value is 0 when x is -1. That checks out. Now let's check another point. X equals 1. Y should be 2. Now in my equation here, if x is 1, y is going to be 2 squared, which is 4. Uh-oh. So what does that mean? That means that there's going to be a coefficient in the front that we need to solve for. So we have to go one step further, and we know that g of x is going to be equal to ax plus 1 squared. So, and like I just said, when x is 1, y should be 2. So we have 2 is equal to a 1 plus 1 quantity squared. So 2 is equal to 4a, which implies that 2 over 4 is a, or that 1/2 is a. Now, using this, we can write our function, which is 1/2 x plus 1 quantity squared. And it checks out on both of our ordered pairs that we choose. In fact, if we choose another ordered pair, such as it looks like -3, when x is -3, we should get 2 as well. That will check out because when x is -3 at -2, quantity squared, which is 4, times 1/2, which is 2. So this checks out. So this would be our final answer for the problem. It's always important to check your work with whatever graph you're given. Thank you for watching. Have a good day.